Dear friends, today we are going to see how we will find the lower sum and upper sum of a given function. If you are given a non-negative function f, we want to compute the area capital A under the function, it is a graph on closed interval a b. What do you mean by lower sum? Lower sum for function f on closed interval a b is defined to be area under the graph of a non-negative step function g. That is very important, it is non-negative and it is a step function g for which the value of g of x is always less than or equal to the value of f of x on closed interval a b. If g of x is equal to k I, means the value is k I for all the subintervals x I minus 1, x I of length delta x j for j equals I 1, 2, 3 etc. up to n, then by the inclusion property of the areas, you can see that sigma I equals 1 to n k I into delta x I is less than or equal to capital A. Now, for upper sums. In upper sum for the function f on closed interval a b, you can see that the definition is like this. It is taken as the area under the graph of a non-negative step function again, but the step function is defined to be h of x. That is, the step function h of x is greater than or equal to the step function f of x, means f of x value is always less than or equal to h of x, and the value is equal to m I on the jth subinterval, that is x j minus 1 x j of length delta x j, j is equal to 1, 2, 3 etc. up to n. By inclusion property again you can see that capital A is less than or equal to sigma j equals 1 to n m j into delta x j. So, just see this figure 5.4. In the first figure, y is equal to f of x is the graph which you have drawn, and you are finding a step function, means you are finding a function g of x which is less than or equal to the value of the function f of x, means the graph should be lying inside this function's graph y is equal to f of x. So, you are drawing the subintervals in such a manner that all those rectangles are lying inside that y is equal to f of x graph. Then considering the B section, you are finding another function h of x, in which that function h of x, it is also a step function, it is exceeding the values of all y is equal to f of x. Then you can draw the rectangles like this, and you can see that using the partitions with the different values of the smallest subinterval, we hope to find the step functions below and above of f such that the corresponding lower and upper sums are very close together as we wish. If the number of subintervals is very large, you can see that this lower sum and upper sum will coincide at some point. That is, it is arbitrarily close to the given values, and you can say that it will be a number capital A the area, capital L the lower sum and capital U the upper sum. Capital L is less than or equal to capital A, which is less than or equal to capital U for any lower sum capital L and any upper sum capital U, and this number will be the area under the graph. So, it is possible to find the area of the graph, area of a given graph in this manner. Now, we can see in a problem how we will find the area if you are given the step functions defined in such a manner. So, in this problem number 7, let f of x, it is equal to x square 0 less than or equal to x less than or equal to 3, let we are defining two step functions g of x. The first one, the values are 1 and 4 in the different ranges 1 to 2 and 2 to 3, and h of x, the values are given in the, as in the figure, and the values are given, and you can see that those values are also lying in between the given interval 1 to 3, that is first one it is from 2 you are taking the point and again you are drawing. So, how can you draw the graph of these three functions f of x, g of x, h of x, and how will you find the lower and upper sums for the function which is obtained from the graph? Now, for the solution you are taking f of x equals x square you are given, means you know that y is equal to x square, which is symmetric over and about the y axis with the vertex at origin and lying completely above the x axis. The graph f, how will you find? Then, and the given step functions g and h are given in the figure, and for g, for the figure g, you will see that delta x1 equals 1, k1 is equal to 1 and delta x2 equals 1, then the different values k2 equals 4, then you can, it is possible to say that g of x value is always less than or equal to f of x, that is equal to x square for all in 1 and 3, the line between, and the graph of the step function g, it lies below the value of below the value of f, that is under g it is a lower sum capital L, it is equal to sigma I equals 1 to 2, 2 subdivisions k I delta x I, it is equal to 1 into 1 plus 1 into 4, the final answer is 1 plus 4 equals 5. Now, for the next step function h of x, delta x1 1, m2, m1 is 4 and m2 is given as 9, delta x1 value 1, delta x2 value again 1. You can see that f of x is always less than or equal to h of x for all 1 ranging in between from 1 to 3. It is possible to find the graph of a step function using the above that of f, the area under h, it is an upper sum and it is given by capital M, it is equal to sigma I equals 1 to 2, m I delta x I, that is the value is 4 into 1 plus 9 into 1, 4 plus 9 equals 13. So, this is the method to find the area if you are given two different functions, you are defining the lower sum and upper sum and you found the area. So, by this we will stop here for this class. Thank you friends.